Hey everybody, this is Mr. Piercy. What we're going to be taking a look at in this lesson is how you solve right triangles using trigonometry. Generally speaking, whenever you're asked to solve a right triangle, the expectation is that you're going to find any missing sides or angles. Sometimes you might have to find two sides and an angle. Sometimes you have to find two angles and a side. It just kind of depends on what was given to you. Sometimes finding a missing angle is just as easy as saying uh, some number minus 90 because we know the two acute angles of a right triangle have to be 90. Sometimes finding a missing side is just a matter of using the Pythagorean theorem because we were already given two sides and we can use the Pythagorean theorem to find the third side. But inevitably, we are going to have to use trigonometry to find something, whether it's a side or an angle. Now, this lesson is going to be the first lesson that I'm creating where it's walking you through how do you find the measure of an angle using trigonometry. Well, sine, cosine, or tangent, just those ratios by themselves, were used to find a missing side when I knew what an angle was. Well, now we're going to be using trigonometry to find the measurement of an angle. So since we're now, instead of using an angle, we're looking for an angle, we're going to use the inverse sine, cosine, or tangent. So what it's kind of telling you here in this box is anything that has kind of that -1 in that exponent spot, we read that as the inverse of something. So that would be the inverse of tangent, and then the next ones in the list here would be inverse sine and inverse cosine. Now the way that we access the inverse sine, cosine, and tangent functions on our calculator is usually we have, so here's our sine, cosine, and tangent. Usually they're together, and then the inverse sine, inverse cosine, and inverse tangent. I know those are hard to see, but look at your calculator. Usually the inverse sine, cosine, and tangent is a second function of those buttons. So I'd have to hit second function on my calculator, then say sine, cosine, or tangent. And when I do, it would say something like tangent -1, and it'll just open it up with the parenthesis, and then you can just put whatever that ratio is inside of its own set of parentheses and hit enter, and it'll give you the value of an angle rather than trying to find a side. So here, this is where we're going to practice finding the measure of an angle. Now in previous lessons, what I talked about, whenever we did trigonometry, I explained your calculator has to be in degrees. Here, some people are going to have graphing calculators, some people are going to just have scientific calculators. Each one is going to be a little bit different. You just have to be familiar with your calculator and how you change the setting on it. Some scientific calculators will have a button on it that says DRG. It just has a button that says that. And that's how you change the settings, where D represents degrees, R represents radians, and the G would be gradians. So you just keep hitting that button until you're somewhere, usually at the bottom of the display, it'll say degree, it'll say DEG, RAD, or GRAD to let you know what setting it's in. So for us, all of the stuff in high school geometry is going to be kept in degrees. So make sure your calculator is in degrees when you perform the following problems in this lesson. So here we want to find the measurement of a missing angle. Now the triangle that was given to us, if you do find the third side, the hypotenuse from A to C is going to be 25. This is just a multiple of a 3, 4, 5 Pythagorean triple. But that's not what we're asked to do. We're not asked to find the missing side. We want to know what's the missing angle. We want to find the measurement at angle A. So looking at the figure, here's my angle of reference. So this is the side here that's 16, that's opposite of the angle. The side that's 20, that's adjacent to the angle. Opposite and adjacent, that's what lets me know we're going to use tangent. So tangent says opposite over adjacent. In this case, that gives us a ratio of 16 over 20, which would simplify to be 4/5. Now this is where on your calculator you're going to say second function, then hit the tangent button, and it should open it up with, it should, like it said on the last screen, it should just say inverse tan like that, -1. Why can't I write in the same spot? -1. I think anyway, and then it'll just open it up with the parentheses like that. Then you just type, you could say 16/20, you could say 4/5, they're the same ratio. And when you hit enter, it'll give you about 38.7. Now on your display, it's going to carry it out to a whole mess of decimal numbers. And typically for pre-AP math, we round it out to 3 decimal places, but angles are kind of an exception. Angles will generally round them out to 1 decimal place. So here, at the checkpoint question, go ahead and pause the video and answer this question on your own. Use trigonometry to find it based on what it's telling you to do, and find your answer for the missing angle. When you're ready, go ahead and hit play again and see how your answers look compared to mine. All right. So it's telling you, go ahead and just use inverse tangent, but now we're moving our angle of reference from angle A to angle C. So when we set up our problem, our opposite and adjacent trade places now, and we have a ratio of 20/16. So on the calculator, I say second function tangent, then I'm going to say 5 divided by 4 in that parentheses and hit enter, and we're going to get 51.3. Now this kind of makes sense. We could have found that without really using trigonometry, but this is 38.7, this is 51.3. Because they're two acute angles of the same triangle, they have to be complementary to each other, so they have to have a sum of 90 degrees. We're using trig to make sure that we find everything, because that's the whole point of this. Use trig to find a missing angle. But this is a nice way of checking ourselves. We do know that the two acute angles have to have a sum of 90 degrees. Those do. So we can feel pretty confident with our work when we check it that way. Now here, this is an example where we're going to use inverse for sine and cosine to find a missing angle. It's not giving us a triangle like it did in the last example, so it'll still kind of be up to the student or the person working out the problem to recognize, oh, here's this angle. We know the side opposite of it. We know the side. We know that the hypotenuse is. Then that's a clue to say we have to use sine. Or, oh, here's this angle, and we know the side adjacent to it, and we know the hypotenuse. That's a clue to let us know that we have to use cosine. So the questions aren't always going to say use this, use that. You have to use your observation skills and say, what angle am I using? What sides did they give me? So that way you know what trig ratio to use. But in this case, we'll just go ahead and practice. This is just a calculator skill operation that we're doing here. To find the measurement of angle A, I'm going to say the inverse sine. Oops, wrong button. We're going to say inverse sine of 0.76 and hit that, enter on our calculator for about 49.5 degrees. And then we'll say inverse cosine of 0.17 for 80.2 degrees. Now here, this is where the vocabulary term at the beginning of the video was talking about, solve a right triangle. Solve simply says it says find everything you can about the triangle. Anything that's missing, find it. So they gave us a hypotenuse, they gave us a measurement for angle A. So that means we have to find the measurement at B, we have to find the short leg and the long leg of the right triangle. Now the easiest thing to do is actually find the missing angle first. We can just use the triangle sum properties to find the measurement of the missing angle. And we can say, oh, well, one angle is 23. The two acute angles have to be complementary to each other, so the other one has to be 67. Now here they're using all three angles as opposed to just the two acute angles, but either way, we still get 67 degrees. Now we're going to use trig to find side BC. Well, side B, even though we know now that this is 67 degrees, we're not going to use that 67 degrees for any calculations unless I absolutely have to. Because there's always a possibility that maybe the answer that we found was wrong. If I use a wrong answer for future calculations, for sure, the answers that I get from those calculations will also be wrong. So if I can avoid it, I always try to not use answers that I found unless I have no choice but to use them. So whenever I have a problem like this, I'm always going to stick with the numbers that were given to me for all of my work. So that means we're not going to use that 67 degrees. We're going to just pretend it doesn't exist in the problem. So from the 23 degrees, side BC, this is the opposite side, and this is my hypotenuse. This is where we have to recognize, oh, I have the opposite side and I have the hypotenuse. That means I have to use sine to find that missing side. So the sine of the angle is going to be the opposite side over the hypotenuse. So I get BC over 40 is equal to 23 sine of 23. Get the 40 out of the denominator by multiplying it by both sides. And on the calculator, all you have to do is just say 40 times the sine of 23 and hit enter. So that's why we're skipping that other step, because they wanted me to type in some decimal numbers, which I don't think is necessary. And we find the missing side for BC to be about 15.6 feet. Now for the other one, we're going to kind of come back here and say, okay, well, from that 23 degrees, now we're looking for side AC. Well, side AC is the adjacent side. This is still the hypotenuse. So that tells me we're going to use cosine to find side AC. So cosine of 23 is AC over 40. Multiply both sides by 40 again to get it out of the denominator. And 40 times the cosine of 23 on your calculator gives you 36.8 feet. But again, for our purposes, we're rounded out to 3 decimal places for AP purposes. So that means we now know the measurements of the 3 angles and the measurements of the 3 sides, and we have solved the triangle because we know all 3 angles and all 3 sides. Now here we're looking at an example of a model train where we have an angle of elevation that we're looking for. The angle of elevation is here, and we're given the side opposite of it and the side adjacent to it. So opposite and adjacent, that lets me know I have to use tangent, okay? Now, sometimes having to know those angle measurements is very important, because if you're like an architect and you're trying to build a ramp for somebody that's in a wheelchair or somebody that's in a motor scooter or something that has to be able to go up, well, there's usually city or state laws or even federal laws that say the incline, the ramp can only be so many degrees. So we need to make sure that we're not exceeding that. And that might be the case here. I don't know. It's just a model train. But if it was a real train, we would definitely be interested in what that angle was for the incline. Well, in this case, we're going to just go ahead and work it out. Now, I really didn't like the stuff that they had here. That's why I'm kind of scratching it out. So I did my work over here on the side, where I'm saying anytime I use a rule, I'm always going to write the rules. That's why I say tangent of theta is opposite over adjacent. Substitute the stuff that we know. We're looking for x, so I put x in place for theta. 4 over 96 for opposite and adjacent. Now, because I'm looking for an angle measurement, I say x is equal to the inverse tangent of that ratio, 4 over 96. Type that into the calculator, and we get 2.4 degrees. So yes, we are below the 3-degree incline that the problem wants us to look for. So there we go. Now this last 3 checkpoint questions, these are for you to do. Go ahead and pause the video and try working these 3 problems out. When you have your answers, go ahead and hit play again, and let's see how our work compares to each other. Okay, everybody, hopefully we have your answers and see what we wind up with here. So for problem number 2, find the measurement of angle D to the nearest degree if we're using sine. So again, because we're using sine when we want an angle, I would say inverse sine of the ratio that they're giving us, or the decimal in this case, and we get about 28.7 degrees. So now, problem number 3 says, solve a right triangle that has an angle that's 50 degrees and a hypotenuse that's 15 inches. Now they didn't give me the triangle, so I'm not exactly sure where everything is. So what I did is I drew a triangle so I could see what am I looking for. So I'm looking for 2 sides and I'm looking for 1 angle. because they gave me one of the angles, I just subtracted the one that they gave me from 90 to find that the other acute angle has to be 40 degrees. So that was pretty straightforward. This is very much a carbon copy of the example problem that we worked out a second ago. So now I'm going to find from the angle that they gave me, remember, not the angle that I found, but from the angle that they gave me, I'm going to find the two missing sides. So finding the side opposite of it, using the hypotenuse, says to use sine, so that gives me segment AC, or side B, to be about 11.5 units long, inches in this case. I should have put the units there. And the other side, the vertical side, is about 9.6 inches, the way that I have it set up, those calling them side A and side B. And for the last one, again, it's kind of a carbon copy of the last example that we looked at. Suppose the incline rises 8 inches but runs 120 inches. Is the incline still less than 3 degrees? So I just kind of took the diagram from the last example and used it again, but showing that we're going up 8 inches with going horizontally 120 inches. So when I worked this one out, I got a measurement that's greater than 3 degrees. It's 3.8 degrees in this case. Now, again, for the model train, maybe that's too high. I don't know. So if it's too high, maybe I need to make that horizontal part longer so I can make the angle smaller so it can actually make it up the hill. I don't know. But in this case, all we can say is no, the angle of elevation will not be less than 3 degrees with those values that we have of 8 and 20 for our opposite and adjacent sides. So that's it for this, for this lesson, ladies and gentlemen, where we're talking about how we solve a right triangle, meaning that find any missing sides and any missing angles. And if I'm finding an angle using trigonometry, we have to use the inverse of sine, cosine, or tangent in order to find the measure of those angles. But at this point, we're going to go ahead and wrap it up and stop. But if you've had any questions about anything that I've explained or anything that you saw, by all means, contact me and let me know what those are. And I'll be happy to help you out and work with you on it. Until next time, ladies and gentlemen, thanks for watching and take care.